Good day, students. This is Math 127. This is lesson 0. Typically, this would be covered first day in class to get accustomed to our course note packet. We did put this on video for you in case you want to rewatch it, or heaven forbid you happen to miss the first class. So here it is for you. The main point of this sort of lengthy example is to get a flavor of what statistics is all about. This is not a math course per se. We won't be doing a ton of algebra. It's all about collecting data and using the data to make decisions. Okay? So, a few semesters ago we sent students to McDonald's. On McDonald's website you can look up all the food items, and we learned that each order of small fries is supposed to weigh 71 grams. Okay, that's what's on the corporate webpage. Now clearly, you know, you've been to McDonald's probably, and does every fry order look exactly the same? Do you get exactly the same amount of fries? And the answer is no. Okay, there's variation, fry order to fry order, and essentially that variation is why the field of statistics exists. We're going to study that variation. Okay. The main point of the project was, as statistics students, we were going to check up on McDonald's claim. All right. The question was, are the local restaurants doing what they are supposed to be doing? A question here, common sense will help us answer this. Can we reasonably expect every order of fries to weigh exactly 71 grams? With the hustle and bustle of a restaurant and the employees trying to get food out the door, the answer is no. We cannot reasonably expect every fry order to weigh exactly 71 grams. Think about how fries are served at McDonald's. There's that scooper, and the employee just takes a scoop and pops it into the little envelope of fries. A student who worked at McDonald's told me once it's stuff and fluff. Stuff them in there and fluff them out. Okay. Fry weights will vary order to order. Statistics is all about variation. As the franchise owner, say you're the McDonald's franchise owner, we want that variation to be as small as possible. Okay, if we're practicing good quality control and we're running a good restaurant, the fry orders should have little variation. If there's lots of variation, it might tell us that there's problems with employee training. Okay, so fry weights will vary order to order, and in one way, the whole field of statistics exists because of this variation. So let me tell you what we did. Each semester there's 7A sections of statistics, and in each section the instructor told the students that the 3 locations we're going to look at, we're going to look at Rising Sun, we're going to look at Northeast, and we're going to look at Elkton, the one that's on 40. Okay. In class, students picked which location they wanted to go to. We would have felt bad sending people that live in Rising Sun all the way down to Elkton. So we let students pick their location. Okay. Once we got, say, the Rising Sun, we put all the Rising Sun people up in the front quarter, and amongst the Rising Sun people, say there were 7 students, we said, okay, now everybody has to go get 1 order of fries and bring it back to Cecil College. We don't want the students all going on the same day. If everybody visited, say, Monday after class, that sample would not be representative of all the different times and days. So we encourage students. We said, try to go on different days. Talk amongst yourselves. Try to pick different times, right? It's probably very different at noon on a Friday than it would be at 3 o'clock in the afternoon on a Sunday. So amongst the students, pick different days, pick different times. If Rising Sun was over here, the Elkton folks did the same thing, and the Northeast folks did the same thing. Now, if that was one class of statistics, we had 8 other classes, all divvying up times and days, and over 100 orders of fries were all purchased. Okay, I think that semester a student had suggested that we put the fries in a Ziploc bag before we brought them back to Cecil College. The thought may have been that some fry weight would evaporate on the the way back to the college. I'm not certain I bought that, but we went with it. Students were instructed to, not leave them in the car overnight, just bring them up. We had one scale we put in the math lab. It was a digital scale, and students dumped the fries into this Tupperware container, got rid of the envelope, and weighed it on the scale. And then they recorded in the notebook. We gave them about a week to do it, so they would record their location, the day and the time, and the fry weight. Okay? So that was the gist of the project. On the slide here basically says what I did in Rising Sun. We divvied up the days and times. There's a question here. This happened for all sections of stats. Why would it be important to collect the data that we did? Okay. Well, clearly, and I'll try to squeeze this in on the slide here, we need the sample to be, I guess, representative of the population. The population is sort of all the fries that these three McDonald's are selling, right? Rising Sun, Northeast, and Elkton. And so when we collect our data, we need to get a nice representative sample. So we need the sample to be representative of the whole population. If one group got lazy and just voted a representative to buy 7 orders of fries, all from the same time, just because that would be easier, the data collected would certainly not be very representative of what's happening in the restaurants. Okay? We'll flip over to the next one here. Again, fries were brought directly to Cecil College. They were all weighed on the same digital scale. Why would that be important? Well, obviously, the fries could change. If when we collect data, we want to make sure that we get good data. So obviously, we would want to weigh them as soon as possible. We did use the same digital scale for the whole data collection that we did, right? And so, I can summarize this very bluntly by just saying that it's pretty clear. We want to collect, I guess in quotes here, good data. You can tell if the instructions were more lax, if students could sort of buy the fries, let them sit for 6 hours, weigh them, then the measurements that we get might not be as accurate. And so we were trying to think of that. We were trying to think of ways to get the truest, most representative sample of fry weights, right? And so these were some of the things that we thought of to help collect good data. Once we have that data, imagine what we had. We had over 100 students. They're all writing fry weights in a notebook. That's that raw data, right? And when conducting a study, the researchers are interested in the entire population. Since this project was about our 3 local McDonald's and their orders of small fries, what on earth is the population for this problem? Right? Put yourself in the position of quality control manager for these 3 restaurants. What are we interested in? We're not interested in just the 100 or so orders of small fries that the students collected. We would be interested in every order of small fries sold by these 3 locations. So the population would be every order. Every order of small fries sold at these 3 locations. Now keep in mind, as quality control manager, that population is what I'm interested in, but to analyze this whole population of data, there's got to be thousands of orders of small fries sold every week. Realistically, we can't weigh every single order. It would stall the time that food goes out the door at McDonald's. It would make the job of serving fries 3 times as difficult, adding this extra step. But this is what we're interested in. Okay? In statistics, we take a sample, of course. All situations, nearly all, it's really hard to analyze that population data. Okay? It would cost a lot of money to weigh every single order from the restaurant's perspective. It would take a lot of time to weigh every order. The solution, and that's what we did in MAT127, we took a sample. Based on that sample, we'll like to make conclusions about the population of all the fry orders. Okay? So the solution here, students, is to take a sample, analyze all of the characteristics contained in the sample. For this example, what was the sample? It was the 100 or so, the actual orders that were collected, right? The sample was the actual fry orders that students collected. In statistics, we want to take a good sample. If we collect good representative data, data that's not biased, then we should be able to use the sample to make conclusions about that whole population. Okay, so there's some big ideas here in this video. Very important. They'll be with us the whole semester. All right, so the next task we have here is to draw a diagram of population versus sample. For this McDonald's example, I think I can squeeze it here on this slide here. So we'll draw these pictures from time to time. Population. Usually we'll use a big circle that's sort of turned oval shape just because of where this writing is on the slide here. There are some symbols here. We'd just like to start using them on day one. Capital N for population size. Again, this is all orders of small fries. I'll save the writing space here, but the population is all orders of small fries sold at our 3 stores, right? Elkton, Rising Sun, and Northeast. And there's a lot of characteristics in this population that we're interested in as the quality control person at McDonald's. I'd be interested in the average weight of all my fries, right? We're targeting 71 grams. I sure hope that my population has a mean that's very close to 71 grams. Okay? In statistics, what we do, we will take a sample. This is typically a very small piece of the population. Now my oval shapes here might be very close in size, but this is usually much smaller. Okay, we'll use the symbol or the letter lowercase n for sample size, because that's the small piece of the big population size. And this sample size, we know what that is. These are the orders actually collected. I have the number. I'll throw in the number here. It turned out 132 altogether. Right, so there was 132 students that went and collected fries. Remember what the variable of interest is. We're looking at the weight. So I will use the symbols today. We'll get into this more in class. But if I'm analyzing weight, I would usually summarize that with a mean. This is the Greek letter mu. You would spell it in English mu. And this is the symbol for population mean. So for my population of all small orders of fries, this mu would be the mean weight. This is the mean weight of all orders. Will this be 71 grams exactly? Probably not. I'll put in parentheses here that as quality control, I'll just say that we hope it's close to 71 grams. If it's too high, then I guess we're giving our customers more fries than they're paying for. If it's too low, then we're not giving our customers enough fries and they'll possibly complain. So this is a parameter. This is a number that describes a population. Once we collect our data, I could calculate the mean weight in the sample And based on whatever the sample tells me, I can make decisions about the population. Based on this data, is McDonald's doing what they claim to be doing? Okay. Now the symbol here, I know it's less than 0, but I'll put the symbols right in. When I'm talking about a sample, the symbol is what's called Y bar, and this would be the mean weight in the sample. Really big ideas here, but super important for the whole Math 127 course. Okay, so if you have questions, make sure that you get them answered. This is the framework of most problems. I have a big group I'm interested in, and I won't be able to collect all that data. So we'll just take a sample, and we'll use this sample data. All right. At the bottom of the page there, get rid of this. Let's see what this says. Students visited their location, returned to Cecil, weighed the fries, recorded some information in the notebook left in the math lab. That information is called data. You could even call it raw data. It's just columns of numbers in a notebook. I mean, at this point, it's useful because we've collected it, but you have a sense we need to summarize this data, right? And how do we do that? Well, if we flip over to the next page, we can see where we're going to head in this course. Raw data is sort of useless. I mean, you can see it in your notebook. I have it in a stat package called StatCrunch. This is what we'll use in the course to do our data analysis and our graphing. But, you know, each row here, this is one fry order, right? All of these rows. This is what a student would have written in the notebook. This is each order of fries. And I have this organized by columns. In statistics, these are the variables, right? The main variable we're interested in is the weight. And you can see that word variable. These weights are varying from order to order. 54.7 grams was the first person in the notebook, 70.5, and so on, right? These are variables, and they do vary. You can see the root word of variables is vary, and that's what we're studying in statistics. All right. So, in statistics, what do? We'll take that raw data and we're going to summarize it. First thing we can do is make pictures. Second thing we can do is calculate some summary statistics, right? And whenever we collect data, these are the two tasks that we'll start with. Always start with a graph. After you make a graph, calculate some summary statistics, okay? If I flip over, I've got some graphs here. You can see on your page in the notebook, there's one for each store. So on the left here is Northeast, in the center is Elkton, and over there on the right is Rising Sun. You may have encountered this graph in the past, other classes, back in high school perhaps. This graph is called a histogram. That's the proper name for it. So we'll definitely want to use this proper name. It's called a histogram. I'll look at Elkton. It's right in the center. I'll make a couple comments on Elkton. What I've done at the bottom of the page is the variable fry weight. And we can see at Elkton that on the low ends, I had some fry weights that got very close to 40 grams. I don't know if they're exactly 40, but you know, this first rectangle here, this goes from 40 up to 50. The way that the graph works is that the taller the bar, the more data there was in that class or that category. So between 40 grams and 50 grams, we had about 10% of our fries were in that rectangle. If you go from 50 up to 60, it looks closer to 20%. This one here, 60 to 70, lots and lots of data. Just about 50% of the fry weights fell between 50 and 60 grams. Okay. Remember what the target is. The web page says what? The web page said 71 grams. That's what McDonald's is targeting, 71 grams. If I put a line here, right about at 71, get as close as I can. Everything to the left of this line, all of these fries here, here, the three left rectangles, these are all underweight. I mean, visually, what can we see about Elkton? Way more than half are underweight. Already we have some clues that McDonald's may not be giving us enough small fries in our orders, right? The ones to the right of this line are the fries that are overweight. Put a check mark there just to use a different symbol. But at Elkton, way more than half of the fries were underweight. If I quickly go over here to Northeast, I can put that line at about 71. And again, visually, clearly, way more than half at Elkton, or at Northeast, excuse me, are underweight. If we go over to Rising Sun, same deal, right? All of these are underweight. The problem might be the worst here at Rising Sun, okay? So visually, we've got some evidence that, you know, we may be able to use and communicate to McDonald's and say, well, sure looks like a lot of the fries are underweight. Step one is to graph. Always make a picture. Once we have a sense of the shape of the distribution, step two is to move on and calculate some summary statistics. First step, always make a picture. Once we have a sense of the distribution, calculate those best summary statistics. Okay. You can see in your notes many of the most important statistics have been calculated. I'm going to slide over to the data here. Here's the summarized data. I've broken it down by location. I've got Northeast versus Elkton versus Rising Sun. And I can quickly summarize what these values are, right? We know what N is. N is sample size. So we had 59 students go to Northeast. We had 40 students go to Elkton. 33 went to Rising Sun. Okay. You probably know what the mean is, and if you haven't used that, it's just the average, right? This is just simply the average. And you've calculated averages before. If you go bowling and you bowl 3 games, add up your scores, divide by 3, that's your average score. For Northeast, I would take the 59 fry weights. I'd add them all up. I'd divide by 59, and for Northeast, the mean fry weight was 65.42. What's it supposed to be? McDonald's is claiming 71 grams per order of small fries. This is quite below 71. At Elkton, the average fry weight was 63. At Rising Sun, it was 62.64. All of these are considerably less than 71. I think we might be starting to build a case that McDonald's might not be filling the fries properly. All right, we'll get through the rest of these, and then we'll cut the video and make a part 2 to this. If the mean is the average, the median is the middle position. I take my 59 orders. I organize them from the smallest or the lightest order up to the heaviest. Okay, so we sort them first. The median is right in the middle. So at Northeast, half of the fries were 65.11 grams or heavier. Half of them were 65.11 or under. So this is a good way to think of the median. This is just the middle position. Minimum and maximum are important. Sort of know what the range of values is. At Northeast, we had fry weights as light as 43 grams. We had fry weights as heavy as 98. If you're a quality control manager, This seems like a heck of a lot of variation, right? They're supposed to be 71. This is almost, not quite, but almost half of an order. This is a good order and probably a third more. So at every location, I've got a huge spread, right? Statistics is about variation. These are important numbers to sort of know the boundaries. Q1 and Q3, these are what are called quartiles. If you know a little something about percentiles, Q1 is just the 25th percentile. So at Northeast, 25% of the fry orders were 59.21 grams or lighter. 75% were heavier than that amount, right? This number sort of splits the data up. 25% below, 75% above. You know the median does 50-50, right? 50% below, 50% above. Third quartile, I'm 75% of the way up. This is like the 75th percentile. So, boy, I mean, this is telling right here. I'll just point out to Elkton. At our Elkton location, 75% of the fry orders were 67.85 grams or below. Supposed to be 71 grams. 75% are 4 grams under that, roughly. So maybe big problems at Elkton. Last thing we'll talk about on this video is this STD-DEV, standard deviation. This is super important. Statistics is all about variation, so we need to measure that variation. If I'm the quality control manager at McDonald's, I want my fry weights to have very little variation. That means as people come and order fries, basically you know what you're going to get, right? They're the same almost every time. This number, standard deviation, helps us measure the spread. If there is a lot of spread in fry weights, and I sort of think that there is just looking at the quartile or the minimum and maximum, this number here will get big. If there's little variation, which would be the goal, then that standard deviation would get small. Okay? So to wrap up this video, I just want to give a definition of standard deviation in words, and then we'll pick it back up next time. Standard deviation is like the average distance or you could say typical distance to the mean. Standard deviation is like the average or typical distance to the mean. If somebody asks me what's the single most important concept in statistics, something that you really just have to know for the whole semester, this is probably the thing I would start with. So I can't think of a better place to stop. Let this sink in until you pick up with the second part of this discussion. Again, standard deviation is like the average distance to the mean, and we definitely need to know this one. Okay, we'll see you next time. Thanks.